So everyone's on 142. Good. Let's go. So we got two new words there. We're going to be discussing them in a moment, which is which. But for now, we're going to talk about some other stuff you need to know before I can explain those things. So let us begin, cabbages. A set. That is a word I'm going to be using all day, all unit. Please make sure you are aware of it. That's why it is highlighted in yellow. A set is a collection of data. Data in math class is anything we can count. Okay? So, what is a set of things in this room? Desks. Excellent. What's another one? Pardon? Recycling bins. Excellent. Give me another one. People. Excellent. All right. So everybody knows what a set is, yeah? Easy peasy lemon squeezy. So we're going to use that example. We're going to say people. That works just fine for me. The next word, an element. That is a single item in any set. All right? So, in this room, we have the set of people, which is made up of how many elements? There's like 26 of us in here, but yeah, whatever, right? There's all you guys and me. Everybody cool? So, an element, so our example of an element is one of us. Now, here's the thing. That set, if the set is people, does it have a subset? You know what set means. So let's think about what is a subset. Do you think? If a set is all of us, what would a subset of all of us be? Pardon? A section of us. Yeah, excellent. So what would a good subset be for the set of people in this room? That would be better. Girls and boys. Right? Everybody cool with that? So the whole set is people, but we can split it into two subsets, girls and boys. Right? Now each subset is made up of elements still, right? David, you're in the boy set, the boy subset, and the set of people. Whereas Andrea is in the girl subset, but still in the set of people. Everybody cool? All right. Okay, single item in any set, example, one of us. Excellent. And finally, a relation. Okay, a relation is anytime we measure elements of one set against elements of another set. Okay? Everybody cool? So an example of that would be, there's a set of kids in here. There's a set of kids across the hall. If we did any sort of comparison between you guys and them, that would be a relation. Everybody cool? That's too big to write out, so I've just explained it. Everybody good? All right. So down at the bottom, you have a graph of dog height. Now, before we go too much further, I want to make sure that we are aware of a few things. Graphs need 4 pieces of information on them. 1, they need a title. Please make sure you give all your graphs a title. 2, I'll wait till my screen wakes up. 2, they need, oh, I don't want to do that yet. Labeled axes. I'm going to highlight them in green. I'm going to shrink this down a little so I can get it all on the page in one go. Okay, that's the second thing every graph needs. Okay? Remember, from the 9th grade, the x-axis is horizontal, and the y-axis is vertical. Label axes, and the third thing they need are, number 3, they need scales. So how big each line is. Now this is a tough one to show a scale on the bottom because it's not numbers. But you need those numbers there to show how big each variable is. And the fourth thing it needs is the data, which is all of this. Everybody cool? Got to have all 4 things. Now, I need to erase this highlighting for a moment. I'm going to ask you some questions about this graph right here. What are the sets? What are the 2 pieces, the 2 sets of information on this graph? Ecti. Dog types is 1 set. Excellent. Dog types. Cool in the gang. What's the next set? Pardon me? The height. Perfect. So he's got the 2 sets. Wonderful. And what else do I want to ask about that right now? Nothing. Don't ask anything about that right now, but we're coming back to this graph in a second. Turn your page over. It should just be turn the book over for you guys if this printed right. Excellent. Now, functions. A function needs to be written here. Wait, I lied. I'm the worst kind of liar. Flip your page back. Now that we know what those 2 sets are, let's take those 2 sets and let's make a relation. So a relation means we take an element from one set and we measure it against an element from the other set, right? So the first set that Ekdeep mentioned was dog types. So what's the first dog type on that graph? Hound. And that's 1 piece of data, that's 1 element of the set, yes? What is the element in the other set that compares to hound? 60, excellent. What's the next one? Chihuahua, which is only on there because they exist. I normally refuse to ever legitimize the existence of any dog that small. Because if it couldn't live in the wild, it doesn't deserve to be alive. And because Chihuahuas don't actually exist, people had to create them. Huh? Do we need to do a biology lesson? The same way people create everything. You find something that is almost what you want in nature, and then you find other things that are almost what you want in nature, and you breed them together, and then you keep breeding their babies together until you get what you actually want. That's how we get giant horses. That's how we get all those things. Selective breeding. That's how everything happened. In the animal world. So, the next one is Chihuahua. Blech. And what is its relation? 12. Because again, it's too little to deserve to live. What's next? Corgi. Most people don't know what a Corgi is. Do any of you know what a Corgi is? Yeah? They're those little dogs the Queen has. They look like a normal dog, but they have stubby little legs. Kind of like, not like a wiener dog, because wiener dogs don't look like a normal dog. Wiener dogs look, again, like something that shouldn't be allowed to live. Although, if you ever get a chance, Google wiener dog races. It's very, very funny. Whippets and greyhounds, that's exciting racing. Wiener dog racing is just funny. Mostly because it's sad. Because you see what would really happen if wiener dogs had to go out and live in the wild. Then next we had Lab, which is an actual good dog as far as dogs go. 45. And then we had Shepherd, which is another good dog as far as dogs go. 45. And amazingly, my dog's a mix of those two. And then the Malamute. And the Malamute is 80, which is wonderful, except when you understand that 80 centimeters of height means a big old dog. So everybody cool that we have 2 sets of data there, right? And everybody cool that those sets of data are related, yes? If I say, how tall is a hound, can you tell me? 60, excellent, because you have a relation, yes? If I ask you, what dog is 12 centimeters tall, can you tell me? Yes, it's a rat. That's really where the Mexican legend, or the urban legend of Mexican giant rats came from. They're wild chihuahuas, I believe. Okay, now here's where we get into trouble. What dog is 45 centimeters tall? Labs and Shepherds. You don't know which one it is, do you? But can you answer the question? I'm thinking of a dog that's 45 centimeters tall. One dog that is 45 centimeters tall. Which dog am I thinking of, Harmeet? Wrong, Shepherd. I know, that's the point. Wait, let's do it again. See if you can figure it out. I'm thinking of one dog that's 45 centimeters tall. Which one is it? No, I just told you it was a Shepherd. I just told you that. Everybody heard me. I've got it on video. I just told you it was a Shepherd. Let's see if we can do this again. Are you ready, Harmeet? I'm gonna have to change your interim. I'm thinking of a dog that's 45 centimeters tall. Which dog am I thinking of? Yeah. See, you got it. No problem. David, I'm thinking of a dog that's 45 centimeters tall. Which dog is it? Wrong. It's a Lab, David. I was thinking of Shepherd when I was talking to Harmeet, not you. You're not Harmeet. You're a different element from a different set. Come on, David. Anyways, all of you should understand the point I'm trying to make. And Harmeet's already given us the answer, because Harmeet thinks I'm a dink and I'm going to change every time. Even though I didn't, I kept saying Shepherd every time for you, Harmeet. But the point I'm trying to make is there's no way she could know, is there? Why? Because there's 2 of them. Everybody understands that, yes? So, because of this right here, not the 142, the 45s, because of that right there, we have what is called a relation. And the reason it's a relation is because Lab and Shepherd do not give a unique... I'm going to ask you two to shut up. I've been very pleasant yesterday, and I didn't say a word, and I let you do whatever the hell you wanted. Because I'm a nice guy. Remember, 1 day's a week, so that means I let you be chumps for a week. I'm stopping it now. If I'm talking, you're not. If it happens again, I'm going to separate you. If it happens again, I'm moving one of you in the hall so you can do your 6 hours of summer school by watching my videos at night. Got it? This is when you say, yeah, Mr. Myers, we got it, because those are pretty clear instructions. Yes, Mr. Myers. There you go. Now the rest of you, hopefully, will see what just happened there and fix your behavior. Because I was very pleasant yesterday to the fact that a very large subset of the elements of this room didn't do a very good job at work yesterday. These do not give a unique answer, do they? If I take Lab and Shepherd out of here, I can't fool anybody, can I? But with Lab and Shepherd in there, this becomes what we call a relation. The reason it's a relation is every dog does not give a unique height. Everybody cool? Now we got to turn the page over, because now we get to what is called a function. And a function is a specific type of relation. What makes it specific? Come on. Come on. Save the world. What makes it specific? In a function, and I'm going to highlight the word function because it's yet another new word. A function. It's barely readable, but whatever. In a function, each element in a set relates to only one element in the other set. So the dog thing doesn't work, does it? Because if I say Lab, that goes to two elements in the other set, right? There's Lab, Chihuahua, Hound, Shepherd, Malamute, Corgi. And there's 60, 12, 30, 45, and 80. And Lab and Shepherd both compare to 45. So that makes that a relation. Everybody cool? All right. If I take Lab or Shepherd out, do I have a function? Yes, because every dog relates to one single height. Everybody good? All right. So let's look at these two scenarios, and you can tell me if it's a relationship or if it's a relation or a function. Each month of the year relates with the number of days. So first thing I want to talk about is what are the elements? What are the elements in each set? I've got set 1 and set 2. So in set 1, what are the elements? One sec, I got to make this delete because, as usual, it's not working. I watched 2 episodes of Scorpion last night and watched them save the world twice with their surfaces. It's about a bunch of geniuses that do stuff and save people. It's technically, the guy really exists, the guy that the show is about, but I don't think he did all the stuff that that's on the show, or I probably would have heard of him. Anyway, Harmeet is absolutely right. There's one set is number of days. So what are our options? No. How many days are in a month? I can have 30, right? I can have 31. I can have 28. And I can have 29. Everybody forgets leap year. Those are my only options, right? Everyone agree? Okay. And what is set 2? Those are the months. And there's Jan, Feb, March, April, and so on. Everybody agree? Right? Okay. Now, obviously, this is at least a relation, isn't it? Because every month has days in it, right? Okay. So, obviously, this is a relation, but I want to know if it's a function or not. So, January has how many days? 30. Oops, dumbass. 31. Is that a function? Yeah. January is one thing. It relates to one thing in the other set. Yes? So it's a function. Agreed? Okay. February has how many days? 28 or 29. Is it a function? Not anymore. Because February relates to 2 different options, right? Now you could say, okay, Mr. Myers, this year, 2017, it's a function still. Because February in 2017 only had 28 days, right? So is everyone still okay? If we're talking about just 2017, is it still a function? Okay. March has how many days? 31. Now is it a function? No. Why? Because January's already taken 31. Is everybody with me? April's 30, so he would have still been okay. Is everybody good with this? So this is a relation because Jan and March are 31. If I say to you, how many days does May have? You can all say 31, right? When you remember the stupid little poem that you learned in grade 3 or whenever you learned it. See, kids don't know that poem anymore. 30 days has September, April, June, and November. All the rest have 31. And then it doesn't become poemy anymore. Except February. Really? Everybody my age knows it. If they went to school in Canada. Doesn't really work in other languages. Mostly because the months have different names. So. You guys are lucky that the French months didn't take over after the French Revolution. We'd be in the middle of Thermidor right now. Yeah, because it's hot. Summer. July was Thermidor. True story. The only reason we use that anymore is there's a term in political science called the Thermidorian reaction. And that's the point of a revolution where most of the people involved in a revolution realize that it's gone too far and they want to stop, but the leaders of the revolution keep going. So in the French Revolution, it was when they were chopping everyone's heads off. Everyone's cool with all this relation? Going once, going twice, going thrice? Okay, let's do a slightly more difficult one. Every name on my class list refers to a student in my class. So what is set 1? What is the first set of data? Names. All right. What's the second set of data? Students. Okay. So, David Kwan. Is that kid right there? Right? Yeah. Red shirt kid, front of the room. I don't want to write all that out. We know who David Kwan is, yeah? Yeah. Right? Okay. Harmeet Bains. How many Harmeet Bainses are in here? 1. Everybody good? Yeah? Okay. Relation or function? Function. Why? Function because each name IDs one student. Now, we in this class, it's very rare that this happens for me because normally I'm able to do what I'm about to do and it works perfectly. What if I went by only first name? Would it still be a function? In this class, yes, because nobody's got the same first name. Okay? I'm about to do last names. What if I went by last name only? Why? Because there's a lot of Sidus in here, right? At my school, I often choose Gill. A lot of Gills, right? If you're at a school in Vancouver, say a lot of Wong. A lot of Wongs. If you're at a school in Dublin, Ireland, a lot of O'Sullivans, right? You can't do it always. Everybody with me? So last name wouldn't work. First name in this room happens to work, but it often doesn't work either. First and last name almost always works. And it wasn't until 2 years ago that it didn't work. So I actually had 2 Jaspreet Sidhus in my room. And they even had the same middle initial. So it was I couldn't even go to middle name with that one. Huh? I don't remember. No, it was an A. Jaspreet A Sidhu. No, it was a K. Maybe it was a K. Yeah, then it must have been a K. Another year, and then 1 year later, I had 2 kids with the exact same name, but one was a boy and one was a girl. 2 Amrinder somethings. Oh, excuse me. That's my text. That's the text message from my buddy who runs my baseball team. It's the theme from Fat Albert. I need my participation medal for basketball. You know, if they gave me a participation medal for basketball, I would still know I sucked. It's always a big gag at my school when we do the teacher versus student basketball game. Because, yes, every year. You can ask those 2. It's funny. I wear high socks, short shorts, little tiny basketball shirt, like you're supposed to in basketball, not those stupid giant basketball shorts that look like parachutes that they wear now. I wear my Converse, wear a sweatband, and I score exactly 2 points the whole game. And it's usually because I got fouled. And I often get at least 3-4 fouls in a 20-minute basketball game. All right. Function. We talked about that. Everybody in my life has their own text tone. So I know who's texting me without looking. It's fun. Like when my mother-in-law texts me, it plays Wicked Witch of the West from Wizard of Oz. No. My wife and I had our 18th anniversary yesterday. She doesn't care about much. When my mother-in-law phones me, it plays the Star Wars. It goes don 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 don. Yep. When my wife phones me, it plays the Queen song "Fat Bottom Girls." Not because my wife's fat, but just because that first line. Oh, you're gonna take me home tonight? My wife calls, and when she texts me, it says "Hello, nurse." From no, it's from Animaniacs. It was an old cartoon. Every time they saw a hot woman, they go, "Hello, nurse." So when my wife texts me, it goes, "Hello, nurse." When my son texts me, it plays the theme from Zelda. That's an old video game. And when he phones me, it plays Mario Brothers. When my daughter phones me, it plays Short Skirt, Long Jacket because she loves that song.
Hey, this reminds me. Just say Mario Brothers?
Yeah.
Mario.
No, it's Mario Brothers.
Mario.
I know, guys. Okay. And when my daughter texts me, it's I think it's the theme from Gravity Falls. Gravity Falls is a really good cartoon. You should watch it. It's really good. Well, then I guess you won't be watching it. When Dougie texts me, it's Fat Albert. When my other buddy calls me, it's the He-Man theme because he's super good looking. When another buddy you won't know that reference, so it won't work. Another buddy who flew in the Navy, he was a Navy pilot, so when he phones me, it's the Top Gun theme. The theme from the movie Top Gun. Dun, 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 dun. Top Gun. Tom Cruise flying movie, nothing? Okay. Yeah, I got lots of them. My other buddy who shoots guns all the time, he's a real gun nut. When he calls me, it's the A-Team. The one that makes people laugh the most is when my mother-in-law texts me, and it's... People laugh at that.
What does your mother-in-law text you?
My mother... You guys don't get this. When old people in your life get a hold of new technology, they use it.
Oh, they just...
It's the stupidest text in the world, and they're all badly done. All right. Let's move on. Except, as usual, we can't. It's in fine form today. My wife says I'm supposed to be thankful because her school doesn't give her any kind of technology. She teaches at Mission Central. I say I would rather have no technology than technology that doesn't work. That's just me. Dependent variable. Okay, guys, 4 new words here, of which you already should know the definitions. What does it mean to be dependent? No. Dependent, David. No, Amrit. Dependent. You rely on somebody. All of you are most of you, I shouldn't say all. All of you are dependent on your parents or some adult in your life for your food and your shelter and your clothes. I don't think any of you live on your own. If you do, I apologize for making that assumption that you live with somebody else. My children are dependent upon me for clothes, food, and shelter. I am dependent on my job to provide clothes, food, and shelter. Everybody got it? That's what dependent means. You depend on somebody. You need them to do your whatever you need to do. So what is a dependent variable? A variable that depends on something else, right? So a variable in regular language is, of course, anything that is unknown, yes? Or something that changes. It's variable. So a dependent variable is the set of elements that depend on, I had to wait a second, that depend on another set. So think back to our dog version. There's 2 variables there, yes? The 2 variables are type of dog and height of dog, right? Okay, so keep that at the front of your head. Next one is independent variable. And that is obviously the set of elements. And I don't really need to write set of elements. I can just write set. Set of elements that stands alone. Just like independence does. Okay, so now think back to our dogs. The 2 sets were heights and types. Which one of those was independent? The dogs. Right, Fawaz? Why? No. That's the wrong answer, Fawaz. Brooklyn. You're getting warmer. It has something to do with the actual quality of the dogs. If I were to call a friend of mine who owned a German Shepherd, and I were to walk that German Shepherd in here and sit him right there, could you guys identify him? Yeah, you'd be like, oh yeah, it's a German Shepherd. I got this. Everybody with me? Okay. If I brought in a piece of paper that had the number 45 written on it, would that mean anything to you? No. Do you all follow me? The dog is a dog regardless. The number 45 doesn't mean anything. Everybody cool? Okay. So the dependent variable, I did the independent variable first. So our independent variable was dogs, and our dependent variable was height. Now, there's a couple of tricks to this. Fawaz gave us one of them. The dependent variable is often, and please highlight often, because it's not always, is often graphed on the y-axis. Which, you guys are smart kids, what does that mean? The deep independent variable. That is often graphed on the x-axis. Okay? Now look at these definitions. There's the dependent variable and the independent variable. That's the actual variable. Everybody understand? The domain, and I'm going to highlight that in yellow. I lie. I'm going to highlight that in blue because the domain is related to the independent variable. And the domain is the actual values. So it is the elements of the independent variable. So think back to our dogs. If the type of dog is the independent variable, because that's the thing that changes, right? What is the domain? So what are the actual elements of that? The dogs is the variable, but what are the actual elements of that? What values make up the domain? The actual breeds. So what were they? Lab, Shepherd, Corgi, and so on, whatever they were. Does everybody understand that difference? The independent variable is the dogs, but the domain are the actual values within that independent variable. Is everybody cool? Okay. Which means, that the range must be what? The range must be the actual values or elements of the dependent variable. And what were they? The height is the dependent variable, but what were the actual values of it? Whatever it was like 30, 12, 45, and so on. Everybody cool? Everybody cool? Okay, now we got to do a little bit of housekeeping here on the bottom of the page. Don't turn the page over. We got to do a little bit of weird stuff down here. Couple of things. One, independent variable. I'm getting lazy. IV. We also call it the input. The dependent variable, the DV, we also call that the output. And the last thing you got to know is we write these sets with funky brackets. Okay? So when I have to write the input, which is the domain, when I'm actually writing a domain, we use brackets that look like this. Oops, I screwed that up. The devil horn brackets from emojis back in the day. You guys don't need them anymore. Those pointy brackets. When you're writing it out, just make them a squiggle. I'll know what you mean. So in here we have element 1, element 2, element 3, and so on, and then the squiggly bracket. Same for range. Element 1, element 2, element 3, and so on, with squiggly brackets. Everybody cool? Now, there's actually a whole long way to write these out. It's not important for you guys at the grade 10 level. It's not important, really, till you get to pretty high-level math and you're doing set theory, which isn't a big deal. As we come to them, I'll try to remember to show them to you. All right, let's turn the page over, 144, and see if you guys are getting it. You can tell how old my notes are by how low the minimum wage is and the fact that there's not a Flying Wedge pizza in Abbotsford anymore. Which is too bad, because Flying Wedge was delicious pizza. So, Sandy's getting a job at Flying Wedge Pizza. She's being paid $9.50 an hour. Her hours worked are related to her pay. Obviously, right? That's the relation. Okay. So, which of those is the IV and which is the DV? Talk about it with your neighbor for a sec. Don't yell out an answer, please. Think about it for a moment. Which of those two variables depends on the other one? Five, 4, 3, 2, 1. Who's going to give me an answer? Ekti. The dependent variable. Okay. Okay. Why do you think that?
Well, the dependent because if their hours, like whatever she works in hours, like how much she'll get paid.
Uh-huh. So you just said whatever she works in hours decides how much she gets paid, yes?
Yeah.
So doesn't that mean pay depends on hours?
Yeah.
So it's the reverse of what you said. The independent variable is the hours. The dependent variable is the pay. Because if she works no hours today, Tuesday, is she going to get paid? No, she isn't. Do those hours pass by anyway? That's how I usually like to remember what the independent variable is and what the dependent variable is. The independent variable applies to everyone, whether they're in this question or not. This question is only talking about Sandy. But are all of us passing hours today? Are we getting paid? Well, some of us are. Are we getting paid? Are we getting paid by Flying Wedge Pizza? No. So therefore, the hours must be independent. Everybody with me? Now, the next question is subtly different, right? Because the next question does not ask for the variable, it asks for the domain. And the domain is this set of elements within the independent variable. So what are the options that this girl, Sandy, who could be a boy, I suppose, what are the elements of this independent variable? What's the fewest amount of hours that could be worked? 0. Maybe they didn't work that day. So the domain, which I'm going to draw in blue, squiggly bracket, first element 0. What's next? 1. What's next? 2, 3, 4. Pay per week. So what's the most she could work in a week? 40 hours. Because after 40 hours, is she getting paid $9.50? No, she's getting paid overtime, right? Okay. So what then is the range? If she didn't work at all 1 week, what's her pay going to be? 0. What if she worked 1 hour? $9.50. You couldn't really work 1 hour, could you? Legally, the shortest shift you can work is 4, unless you give permission. But for math purposes, we're going to keep doing this. What would 2 be? 19. What would 3 be? 28.50. Right? Up to what? Whatever 40 times 950 is, right? 360, 380. Does everybody understand the difference between the independent variable, which is just what we're counting, and the domain, the actual count? Everybody cool? Yeah? Everyone uses them uses them to mean the same thing, but they're not the same thing. Everybody good? All right. Is it a function? Yes or no? Yes. Why? Exactly. The second she works another hour, she gets paid a different wage. Right? Okay. So this is a function. Why is it a function? Yes. Because each input or IV value gets me a unique output or DV value. Is everybody good? Okay. Look at the next question. What are those things that I've written there? You got to think back to grade 9. They're coordinates, aren't they? X's and Y's. How do you find that dot? What do you do? The first one's an X. So you go 1 over here, and then what? 3 up. 1, 2, 3. Everybody cool? So, since we only knew, we have decided, we have made this decision as math people that X's go first, yes? And for you to know where to go up, you had to go out first, right? So that dot, the up, depends on where you are on the x-axis, yes? So that should tell you something new as well. The x is the IV, and the y is the dV. So in this question, can we name the independent variable? That's giving it a value. Can we name it? No, because we don't know what we're counting. We don't know what we have one of, do we? So you'll notice in this question, I didn't put what's the independent variable, did I? I just asked what the domain and range are. So in this first one, what is the domain? Which I've been writing in blue. Excellent. Squiggly bracket, 1, 2, 3, 4. because those are the x values. What is the range? 3, 6, 9, 12. Because those are the y values. Now, is it a function? Yes or no? Why? Right, because every x gets me how many y's? 1. When I go out to 1, I'm at 3 on y. 1, 3. When I go out to 2, I'm up at 6. When I go out to 3, I'm up at 9. Everybody cool? So that is a function. Okay, you guys do the next one. What's the domain? 1. 0. -1. We don't need 0 again. We've already used it. Because remember, the domain is just the elements in the set. So once I name it once, I don't need to name it again, right? Squiggly bracket. What's the range? 0. 1. -1. Now, a couple of things about this. Normally, we write these things least to greatest. So we didn't do that here, but that's fine. Is it a function? When I input 1, how many outputs do I get? Just 1. Is it a function so far? 1 input gave me 1 output, right? So now I'm going to enter 0. What do I get? 1. What happens right here? Same input. What's that? A different output. So is it a function?
No.
So if it's not a function, what is it? It's a relation. Everybody cool? Okay, what about the third one? What's the domain? 2, 4, 6, 8. Who do we appreciate? Math, math, rah, rah, rah. No? You guys. Math loves you equally. Thank you, Harmeet. Bonus points for you. What's the range? 3, 5, 7, 9. Function or relation? Function. Why? Each input only has 1 output. Can everybody do this from a chart? Yeah? All right. Let's look at it on a graph. So on this graph, I have 7 points, yes? So there's 7 pieces of information on here, yes? And each of those points has an input and an output, yes? The inputs are the domain, the outputs are the range. So what is the domain here? Go least to greatest. What is the smallest domain value here? -2, -3. What's next? Then what? No. 0. Then what? Then what? Then what? 3. Everyone agree? How did I find that? I looked only on the x-axis. Everyone agree? Okay. What then is the range? -3. -2. -1. There's a 0. Then what? Then 1, because we go least to greatest. Then 2. How did you find those, Simran? You went down the y-axis, -3, -2, -1, 0, because it's right there, 1, 2. Does everybody agree? Okay. Now, is it a function? No, this is a relation. Why? Because this input of -2 has 1, 2 outputs. So that allows us another tool to say if it's a relation or a function, and that's on page 145, the vertical line test. This only works on graphs. Highlight that somehow. At least the word only. You can only use this if it's graphed. So everybody draw an axis on the left. Everybody draw a couple of dots. It doesn't matter where you put them. Is that a graph? Yes. Okay. I'm going to take this red line, which pretend is perfectly vertical, and I'm going to move that red line along the graph. At that input, how many outputs are there? 1. What about there? What about there? What about there? What about there? Excellent. That makes this a function. What if I put a dot right there? Now it's a relation. Everybody with me? Does it change if it's a line? If I go like this. And I take my red line, my good friend, vertical red line. Am I okay? Function, yes? Okay. What if I do this blue line, which is coming out red? That's a relation. Why, Amrit? Because what's going to happen halfway through that? When I take my vertical line and I go along here, I'm at function, 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 function. Oh! Relation. Why? Right. Because at that x value, I have a y value there, I have a y value there, and I have a y value there. Everybody with me? Okay. So here I have a graph, yes? It's a little hard to see the dots. I'm going to make them a little easier for you guys to see. Relationship or function? It's a relation. Why? Because at input -1 and input +1, there are 2 outputs. Everybody good? Okay. Now, tell me the domain and tell me the range. The domain is what? And do it in the right order, please. -3, -2, -1, 0, 1, 2, 3. Maybe that'll show up. I do, right? It's amazing. And what's the range? -2, -1, 0, 1, 2, 3. Now, please notice something. This is something kids screw up all the time. Don't write this down. Just answer this question in your head. Is the point -3, -2 on the graph? Is it? No, it isn't. So what kids do is when they list the domain and range, they see this and they think that's an X and a Y that are going together. But they're not, are they? That is just a domain value and a range value. Is everybody with me there? 3, 2 is on the graph? No. What's the pair that goes with -3? 0. The input is -3, so the output is 0. Everybody with me? Okay. What is different about the graph of B compared to A? Because it's still a graph. It's got an X and a Y. It's got values on it. What's the difference? Pardon? It's a line. Absolutely correct. Yes? So this guy's domain lives where? On the X or the Y axis? The X axis. And what is the first value of that domain, Amrit? -3. Right? You can see that this starts at -3, yeah? But what happens? It goes where? Doesn't it go all the way to +3? Does it ever stop? No. It has every single value from -3 up to +3, doesn't it? Because it's not dots, it's a solid line, yes? So can we write it the same way that we wrote it up here? No, I obviously cannot. Because up here, is there any input between -3 and -2? No. Go. Okay. So, we notice you look like a doctor. You all scrubbed up, buddy?
Yep.
Ready to perform the appendectomy?
Yeah, whatever that is.
Removing your appendix.
Yep.
Alright? So, we all notice that in this case, our inputs are single points. But in this case, our inputs are every point. Even the ones between -0 or -3 and -2. So we write this differently. Okay? There's two ways to write this. I have to teach you both ways. One way is this. -3 is the lowest value, yes? So we write -3 less than or equal to X, and X is less than or equal to +3. And we put the squiggly brackets around it. Harmeet, what's that mean? Exactly. Shut up and pay attention. -3 is less than X, because -3 is the lowest value. It's equal to X because it's got a dot that is solid there. X is less than 3 because 3 is the biggest value. It is equal to 3 because it has a solid dot there. Everybody cool? So when I'm doing domain of a line, I go as far left as I can, and then I just go along the x-axis. As long as that line exists, I keep coloring in the x-axis. Everybody cool? All right. Now the other way we write that, this is called set notation. The other way we write that is this. We take the smallest value, -3, comma, the biggest value, 3, and then we put a square bracket around it. That square bracket is equal to. So this tells me I go from -3, and I actually touch -3, because I used a square bracket, up to +3, and I actually touch +3. And this is what we call interval notation. Now the tricky thing with interval notation is it only works on lines. You cannot use it if you just have dots. Okay? What then is the range? So just like with domain, I went to the lowest value on the x-axis. So where do I go for range? The lowest value on the y-axis, which is right here, yes? -2. And I actually get to -2 because the dot is solid, yes? So -2 is less than or equal to what? When it was domain, it was x, so what's here? Y. And I go up to what? Up to 3. Now the mistake kids make here is they stop at the end of the line. You got to go up as far as the line goes. And I get up to 3 and I put my squiggly bracket. Now how would I do that in interval notation? -2 with what kind of bracket? Square, because it actually gets to -2. And I go up to what? 3 with what kind of bracket? Square, because I actually get to 3. Is everybody good? Okay. What's different about C? The lines are separate. So I have 2 sets of domain and I have 2 sets of range, don't I? Do I find them differently? No, I find them the same way. So for domain, my first set starts where? On the x-axis, and I go to the far left or right? Left. Negative, what is it, Amrit? Look closer. 10. Right. So I start at -30. Is -30 included? Is that a solid dot? So -30 is included, so I got to draw the equal sign. Then I put an X, and what does this part go up to? -10. Is -10 included? No. So I put the regular less than, and I put my squiggly brackets. What is that in interval notation? Square bracket, -30, comma, -10, round bracket. Everybody good? Because net 10 isn't included. Because it's got a circle. So I go up to -10.1, but I don't actually hit 10. Got it? Okay, everybody cool with that? Then, yes, David.
But it's not included.
That means my inputs go right up to -10, like -10.00000001, but there is no input that is actually -10. I'm not sure why you're confused by this, David. -10 is a number, yes? It's a point on the graph. It is right there. Okay? This line will never actually touch -10. It will touch -10.00000001, but it won't actually touch -10. But you can't graph that. So that's why we put a circle around it. It means it comes up to it, but doesn't actually touch it. Okay? Got it? Okay. So what happens right here, though? It starts again. So there's a new part of the domain that starts with 0. Is 0 included? What kind of dot is that right there? Right there where my red circle is. It's solid, so it's included. So I put the equals, x, and it goes up to positive 30 now. Is positive 30 included? No. So I put the regular arrow for 30. Everybody with me? So what is the interval there? Square bracket, 0, comma, 30, round bracket. Now, because there are two sets here, we have to put a letter U in the middle. And that letter U stands for union. That tells me that the domain goes from there to there, then stops for a bit, then goes from there to there. Everybody cool? Okay, now do it for range. You guys should be able to do it for range. What's my lowest range? And again, you're going to have a union situation. So everybody try that while I have a sip of coffee. And I'm going to restart my... No, I can't restart my computer until I finish the video. All right, what's my lowest range value? Negative 20. Do I actually hit negative 20? Yep. So I got to put the equal sign. Then what letter? Y. And how far up does this first section go? No. Goes up to 0. Does it hit 0? No. How do you know it doesn't hit 0? Because it's an open circle. Squiggly bracket. Now put that in interval notation. Square bracket, negative 20, comma, 0, round. Then it starts again, so I have a union. Where does it start again? 10. Does it actually hit 10? No, so it's a regular arrow. Up to what? 30. Does it hit 30? Yep. So in interval notation, it's a U. Doesn't hit 10, so it's round bracket, 10, 30, square bracket. Is everybody good when they're split? Okay. How do you know what? If it's connected, because there's two... What do you mean by connected? Oh, okay. I see what you're saying. Okay. Because, watch. If I start here, Amrit, there's line, yes? And here there's line, 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 all the way up to 0, yes? From 0 to 10, is there any line? You understand? But then at 10 again, it starts up again. Got it? Cool? Okay. Look at this next one. This next one is really tricky. People have a lot of trouble with this one. What's the domain? Where does it start? Negative 6. Excellent. Is negative 6 included for WAS? Why? Because it's got an open circle. So negative 6 is not included. X. Now, I start going along the x-axis from negative 6. So I go all the way to there, no problem. What happens there? It's got a closed circle, so 3 is included, right? But what happens right here? Does it start again right away? At negative 3? Yeah, so I keep going, yes? Out to here. What happens here? Starts again and goes out to here. Did my domain ever break? So do I need a union? No, I just write it normally. -6 up to what? Is +6 included? Yeah. So what's that as interval notation? Round -6, because we never actually hit -6 because it's an open dot. +6 square. Everybody good? Okay, now range. Kids always screw this one up. What's the range? 3. 6. And 9. Can I do interval notation? Yes or no? No. Why? Pardon me? There's only 3 possible range values, isn't there? There's nothing in between. 3, 6, 9. Does everybody get that? This one messes kids up because you see a line and you try to make this right here work with this because you're not thinking about what's actually happening. You understand what I'm saying? There's only 3 values there. So because there's only 3 values, there can't be an interval. Everybody good? Okay, you guys should be able to do the last 2 on your own. Oh, that is the last 2. Right. Boo. You should be able to do page 270. Now listen, there's a little bit of work here. There's page 270 and 294. And then, so 147, 148, 149, and 150. Now 149 and 150, I'm looking at the photocopying and it didn't work incredibly well. So if everybody could please flip to page 149 and 150. And let's fix this up. Number 1, those are solid dots at each end. Okay? Number 2, every dot is solid. Number 3, it starts with a solid dot, and this arrow goes flat. Right there. It does not continue to go downwards. Everybody cool? Okay. This one you can quite plainly see as an open dot. This one is a closed dot, and that arrow goes flat. 6 is closed dots. Pretty easy to see. Then you turn the page over. And I think that page is all pretty good. Number 2 has an open dot. And number 4, open dots. Five has an open dot and 6 is good. All right, now what I want you to do on these pages is you tell me the domain and range for all of them. And I would say you have until 10:15. Then we talk about those pages. Make sure you can actually do it by checking 147 and 148. That looks like a lot of work, but it's not, because it's like yes or no, or okay. These assignments, not assignments, this work looks big because there's so many pictures. Okay? So you guys go page 147 to 150.